Welcome, everyone, to a pretty special investigation. Today, we're not tracking your usual criminals. Nope, we're going microscopic. We're putting on our detective hats to hunt down some of the most elusive culprits on the planet, human parasites. So grab your magnifying glass. The case is officially open.
And that's the big question, right? How do you catch someone you can't even see? These suspects are masters of disguise, they are experts at infiltration, and they operate right under our noses, or, sometimes right inside them. To solve these cases, you have to think like a detective. You got to understand their methods and know exactly which forensic tools to pull out of your kit.
All right, let's open our first case file. I call this group the infiltrators. Now, these aren't subtle thieves. Their MO, their method of operation, is basically brute force. They break and enter, setting up hideouts deep inside human tissue and just causing chaos from within.
Okay, so this is a classic case of mistaken identity, but one with really serious consequences. See, not all suspects in the tapeworm family are created equal. On the left, you've got Teniasolium, the pork tapeworm. This is our prime suspect for a major crime called cysticercosis. If you accidentally ingest its eggs, it doesn't just hang out in your gut. No, it infiltrates your tissues, it can even get into your brain. Now, its relative, the beef tapeworm, Taenia saginata, much less of an offender. And knowing this difference is absolutely crucial. One might just require some medication, the other can literally require brain surgery. You have to know your suspect.
But here's the thing. No master criminal really works alone, do they? A good detective always looks for accomplices. And get this, in the parasite world, some of the biggest heists rely entirely on an outside partner, someone who acts as a lookout, a safe house, and a getaway driver, all rolled into one.
Let's take the schistosoma heist. The entire operation is completely dead in the water without its accomplice, the humble freshwater snail. The snail basically acts as a safe house, letting the parasite multiply and rearm itself before it releases this new wave of infectious agents. This reveals a critical piece of evidence for us detectives. If you can take out the accomplice, you can stop the crime entirely. It's a classic move. Dismantle the network.
So, taking down the network is one strategy. But what about the culprits who operate as lone wolves? For them, we have to open our second case file, the hidden thieves. These are not your brutish infiltrators. Oh no. Their MO is pure stealth. They live inside you and just quietly steal vital resources, often without the victim even knowing until the real damage is done. So check this out. We've got two thieves here with two completely different targets. First, the fish tapeworm, Diphyllobatherium latum. Its target is super specific. It steals vitamin B12 directly from the food you eat. The consequence? A condition called megaloblastic anemia. Then you've got the hookworm, Ancylostoma duobilali. This one's more of a bruiser. It doesn't bother with vitamins. It latches on and steals your blood itself, leading directly to iron deficiency anemia. Two different methods, same category of crime, internal theft.
And then there's the true master of disguise, Plasmodium, the tiny culprit behind malaria. The genius of this parasite is its hiding place. It doesn't just float around in your bloodstream, where it could get caught. No, it breaks into our red blood cells, the very cells that carry oxygen, and it hides inside them. By doing this, it makes itself effectively invisible to big parts of our immune system's security patrol. It's a brilliant and deadly strategy.
Okay, so we know the criminals, we know their methods, but how do we actually catch them? How do we prove they were at the scene of the crime? Well, for that, we need to open the investigator's toolkit. These are the forensic tests that let us unmask our microscopic suspects.
Every detective has that one reliable go-to technique, the one that just cracks the toughest cases wide open. In diagnostics, we call this the gold standard. It's the most definitive test you can run for a particular culprit.
And for malaria, this is it, the peripheral blood smear. It's honestly elegantly simple and incredibly powerful. You take a drop of blood, smear it on a slide, and you look at it under a microscope. This is the forensic equivalent of getting a crystal clear photograph of the suspect right at the crime scene. You can literally see the Plasmodium parasites hiding out inside the red blood cells. There's no denying it. Case closed.
But, not all suspects are so easy to photograph. Some are way more elusive, hiding out in these hard-to-reach places. And for those, detectives need to get creative. You have to employ some unconventional methods.
And believe me, it doesn't get much more unconventional than this. To catch the intestinal parasite Giardia lamblia, sometimes we use the string test. And yes, it's exactly what it sounds like. The patient swallows a capsule with a string coiled up inside. As that capsule dissolves, the string unwinds down into the upper intestine, which happens to be Giardia's favorite hideout. After a few hours, the string gets pulled back out, bringing with it a fluid sample that we can check for the parasite. It sounds totally bizarre, I know, but it's a really clever bit of detective work to get evidence from a location that's otherwise super difficult to access.
So, after reviewing all these different case files, from the infiltrators to the hidden thieves and the wild forensic tools we use to catch them, what have we really learned? What are the key principles for any aspiring parasite detective out there?
It really all comes down to 3 basic rules in the detective's code. First, know your suspect's MO. Are you dealing with a brute force infiltrator like the pork tapeworm or a stealthy thief like the fish tapeworm? Second, identify any accomplices. Like we saw with schistosoma, sometimes the key to stopping the whole operation isn't the main suspect at all. And finally, choose the right forensic tool. You have to match your technique to the specific culprit you're hunting.
And that brings us to the end of our investigation, but it leaves us with one final, lingering question. These microscopic criminals are constantly evolving, right? They're changing their methods. So what's next? What new, ingenious forensic tools will medical detectives of the future need to invent to stay one step ahead and solve the next great parasitic mystery? Something to think about. Thanks for joining the investigation.